Hi, everyone. Welcome to Arroyo Office Hours Live. This is a chance for all of you, whether you're Arroyo customers, Arroyo curious, or just super into growing and existing in this exciting industry, to share your stories and get all of your burning cultivation questions answered. Each week, we'll spend an hour sharing our findings, walking you through some interesting features, and having a lively conversation about what you're doing, what you want to know, and even help you share your own stories and connect with other people who are passionate about the plant and its potential. My name is Keisha. I'll be your moderator for today's discussion, and we're going to be talking about electrical conductivity and sensors. If you have any questions for us and you're on the call, please go ahead and submit them in the chat anytime. We'll do our best to answer them during the broadcast, but our Instagram community gifted us with a bunch of questions on this week's subject. So Scott, Jason, you ready to go?
Yes, we are. Thank you, Keisha. And
Absolutely.
I also want to welcome everyone to today's broadcast, but especially my dad, Gaylon Campbell, who put together some information on the irrigation of plants in controlled environments that we're going to use as reference material for today's discussion, and also is really the reason why our business even exists. He was a researcher at Washington State University for 3 decades in soil physics, and during that time also founded Decagon Devices, which eventually became Meter Group about 7 years ago. So a welcome to my dad, Gaylon. And we're going to start off talking about EC, and we have some great questions from from people in the Instagram community and our customer group. Like, do you have to run a high EC to achieve better product? And what EC ranges do you want to stay in? And should I decrease EC later in flower? Those are all great questions, but we have to start off first and define what EC is. And to do that, I'm just going to share my screen. And so, Dad, I have this slide deck here. So I'm just going to do that and show this. So how is it defined here, and how does nutrient concentration affect electrical conductivity? Yeah, it's the scourge of the pandemic is the mute button.
There's a linear relationship between the electrical conductivity and the concentration of the nutrient solution.
Okay, yeah. So the more higher the concentration of nutrients in solution, the higher the EC that we're going to get. But and one of the places where people get messed up is on this difference between bulk EC and pore water EC. And is this a good slide to explain that difference, Dad?
Yeah, I think so.
Okay.
That should I go ahead on that?
Yeah, please.
Yeah, the sensor itself, the Terrace 12, measures the bulk electrical conductivity. So if you just put it in some water, it'll measure the conductivity of that water correctly. But if you put it in soil or a horticultural substrate, there are particles in there that hold the water, the substrate itself, and so that interferes with its ability to conduct electricity. And then if the substrate is unsaturated, if there are air spaces, that also interferes with it. And so at a given concentration, the electrical conductivity of substrate at a lower water content could be 100th as much as the conductivity of the water that's in it. And what we need to know is the conductivity of the water that's in it. We call that the pore water EC.
Yeah. So is it correct to say that pore water EC is essentially what the roots are feeling, the stress or lack of stress from osmotic potential that the roots are feeling at any given time?
Exactly. Yeah.
And so this is the first problem that we overcome through converting bulk EC to pore water EC, is that if you're just measuring bulk EC, you actually don't know what plant stresses are being created. So that's really critical to know the difference between the two, and also to know that in Arroyo, we're measuring pore water EC and writing that to the cultivar record, the cultivar's cultivation record. This is how the pore water EC is related to the bulk EC. And I wanted to talk about redistribution. So, well, actually, just really quickly, let's talk about the sensor itself. So, and we did get a question on this that we will get to after explaining the basics of the Terrace 12 and why it's special. We got a question, hey, what is the difference between a Terrace 12 that has 3 prongs on it and a Grodin GrowSense sensor that has 6 prongs on it? So, Gaylon, can you explain a little bit more about the Terrace 12, where it came from and how it works?
Okay, the Terrace 12 has 3 prongs on it. We measure the dielectric of the substrate solution between the center prong and the end prong, and we measure the electrical conductivity of the solution between the center prong and the base prong. And the Grodin sensor essentially has 2 of these Terrace 12s in it. It measures at 2 different levels in the substrate. And so if you use 2 of the Terrace 12s, you would have the same thing at 2 different levels in the substrate. You'd have the same thing as you have with, for measurement purposes, as you have with the Grodin sensor.
Okay. Yeah, and we do make both of those sensors, so we understand very well how each one of them works. The Terrace 12, and the reason why it's so useful in hydroponic growth media indoors, is that it does a better job than any other sensor that we've ever tested at measuring pore water EC, while also getting accurate moisture content reading. And which probe, do you know, which probe is the temperature sensor in, Gaylon?
It's the center one.
Okay, yeah, so those are the 3 readings that come out of the Terrace 12, which are water content from the dielectric, EC, which is pore water EC, and temperature. So let's look at a data trace that an Arroyo customer might see just from watering their plants. And why don't you talk about what's going on in this time series graph and the concept of redistribution of EC?
Okay, the blue line is the water content. The orange line is the pore water electrical conductivity. The yellow lines show the irrigation shots, individual shots that are for an irrigation event. And so you can see as soon as the irrigation starts, the water content immediately starts to climb, and it climbs to the high point that you see here, and then it doesn't continue to go up from that, even though you continue to be giving irrigation shots. And that's because that additional water you're giving is going to drainage. And you can see that initially, as the irrigation starts, the electrical conductivity, or water electrical conductivity, increases. And this is an indication that the plants have used up nutrients from the substrate solution, and so the irrigation event replenishes those nutrients. And then when the when drainage starts to happen, why some of that is moved out.
Mm-hmm. Yep. And Jason, can you share your screen on what a typical AROYA customer sees on their software when they're looking at these irrigation events and how pore water EC and water content look in the actual platform?
Yes, absolutely. So in this case, we're looking at an entire grow cycle, including the veg and flower phases. So it's just starting off to the left side. We can see that during veg, there's just kind of a rough consistency as far as those irrigation events. Whenever those plants are growing in early stages, it's nice to really monitor on a daily basis and keep an eye on how much replenishment you're getting, what's going on with your EC. Are we looking at rising? Are we looking at decreasing? Do we need to get to an established baseline for that plant growth initially? Then here around the May 13th mark, we'll notice that these sensors got moved into the slab. So they went from the 4x4 cube into the slab, and some rooting in type action for a few days here. And then we'll notice the beginning of regular generative irrigation. And as I was talking, this is a development time where the plant is rapidly growing. It's increasing surface area, transpiration rates are going up, and we can see kind of a decrease in the overall water content as that static irrigation schedule doesn't necessarily keep up quite with the growth rate of the plant. What we can also see here is that EC begins to stack right around this May 26th mark or so. The water content, the irrigation schedule was actually increased to try and keep up with the plant's uptake. We're still looking at generative irrigation shots, that short irrigation window, but we can also see that by the quick rise of that EC that this plant is pulling water very quickly, right? These are drybacks in the probably 25, maybe 30% area. That's indicating very healthy growth rate, and that's also indicating that the plant is feeling some generative steering by the way we see the slope of that EC climb very quickly. Now, some of the kind of questions that we get is like, what do you recommend for EC ranges, right? And that's a very generalized question. There's a lot of variables that are going into there. What types of lighting are you looking at? What are some of your environmental parameters? Are those in check, et cetera? And so also what makes that more complicated is when we talk about timeframes and steering intentions. The EC can be very dynamic during your generative shots. So in this case, we're looking at anywhere from say 7 to over 20, because those plants are being driven very, very generatively, and their growth rate is indicating major drop in water content from a day-to-day basis. Now on the right side, we can see a little bit more of that vegetative irrigation, in which case the EC is much more stabilized. As your chart showed, the more irrigations we have through a day, the more likely that EC is going to stabilize. We're replenishing it with new nutrients, whether that's keeping the EC a little bit lower or a little bit higher is going to depend on your feed EC and what's occurring in that root zone. So in this case, some of those vegetative ranges, maybe in the 4 to 7 range. And like I said, there's a lot of other variables that go into play. So if we're looking at LEDs, where there's a little bit of less radiation coming off the lights, then the ECs can be played around with a little bit to be tailored for the exact parameters of that growth environment.
Yeah. And just when people ask about average ECs, so let's talk about a couple of those questions here. Do you run a high EC to achieve a better product? It's not quite that simple. It depends on the phase of growth that you're talking about. It depends on what you're trying to achieve in that phase. So yes, in certain times, higher ECs are better if your goal is to stress the plant. So let's say it is a genetic that takes stress well. So during that early flower period, when running it generative is going to increase your yields and increase bud sites, then yes, high ECs are better. And those are achieved typically through dryback, where you see the EC spike, as Jason was mentioning. And then when you go into the bulking phase, a lower average EC is better because you're trying to keep the plants generative and bulk on those bud sites. And then there was also a question about late in flower. And late in flower is typically when a grower will try to achieve ripening, which is achieved through more aggressive drybacks and pushing the plant more generative. We would expect to see a higher average EC during that time. So the EC that you achieve is going to be, different based on just, a variety of things. Just the time of day will change what your EC is based on when your waterings are or when your drybacks are happening. But on average, if we look over a whole day, generative steering is a higher average EC. Vegetative steering is a lower average EC. And let's dive into a slide now that zooms in on a particular part of a day. And Gaylon, if I could ask you to talk about EC and plant transpiration.
Okay. Again, where the blue line here is showing the water content, the orange line, the electrical conductivity. And now in this case, the electrical conductivity at the end of the dryback period is fairly high. And as soon as the irrigation starts, the water content goes up and the electrical conductivity goes down because the nutrient solution is a lot more dilute than the substrate water. At the end of irrigation, you start the dryback. You can see the electrical conductivity increasing and increases over that whole dryback period. And that's the result of the concentration of the water. The plant takes up a lot more water than it does in proportion to the nutrients that are in the water during this time. And so the concentration in the solution increases during that time.
Mm-hmm. Yep. And so I think, sorry, go ahead.
Oh, that is, in fact, one of the things that you're looking for generative steering is to that ramping up of the electrical conductivity during the dryback.
Yep. Yes. And I noticed, when Jason talks about stacking, I noticed when I was growing my own plants in a tent that when the plants are relatively small, their ability to take up water from the substrate is way more limited. The root mass is smaller. The surface area of the leaves is smaller. Transpiration rate is lower. And, you can only achieve, even with longer drybacks and smaller plants, you can only achieve so much dryback during that dryback phase. And you won't see those ECs start stacking until the plants get bigger and increase their transpiration rate. Okay, let's jump to some of the other questions. This one's, we have a question here. Should the Terrace 12 be used in every plant, or is it okay to use in every tray? This one, while we would love, as a company that actually makes substrate sensors, we would love it if every single plant had a Terrace 12 in it. That isn't necessary and is... you just have to get a representative sample. And typically we talk about here, getting good EC and water content readings from an irrigation zone. It'll depend on how big your zones are, but you need to get a representative sample from that zone. And our recommendation is for indoor growing, one sensor every 100 square feet to get a representation there. And that might be, what would you say, Jason, one sensor every, if we're talking about flower, about typical flower density, one sensor every 50 plants? Is that about right?
Sure, absolutely. And one of the things there to consider as well is looking at the variability of what you're operating, what you're trying to analyze. And if you check out on YouTube, there's a video I did on sensor density, talking about normalized distribution curves, just applying some simple statistical analysis to think about, hey, what is a significant number of sensors for me to have? So if I'm using multiple cultivars in a room, then you'll need more sensors to attribute the different types of population. Those genetics can behave differently. Any other differences in there? Maybe you don't have a great light consistency. Maybe one of the walls in your greenhouse is blocking some sunshine in one of the sides or the corners of that room. If you're playing with multiple types of substrates, you'll definitely need more sensors, because any of those differences across crop uniformity are going to require a better picture. They're going to have different growth rates. They're going to have different population curves, and you'll need to want to segment those out so that you're not necessarily trying to analyze multiple variables with one type of average.
Yep. Okay. And I have a question about EC generally as it relates to plant nutrients. And this wasn't on our list that was submitted, but something I've always been curious about. I've heard about many years ago in Holland, they tried to get an ion-specific sensor that could just tell them the concentrations of everything, nitrogen, potassium, phosphorus, boron, every single thing, manganese, everything that was going to be in the water. While EC can tell you a lot about nutrient concentration, it doesn't tell you anything about your nutrient formula, right? Am I correct there, or what do I need to know about the formulation of my nutrients versus EC?
Yeah, that's an awesome question. And the composition of your nutrients is not necessarily it can't be seen by electrical conductivity. So things that you can do to help keep an eye on that nutritional balance, making sure that the right ions are being pulled up by the plant. Easiest would be a pH of your runoff. So making sure that you're not seeing too much of a rise in your pH. That's going to indicate that the nutrient balance is good and the plant is not necessarily running out of negatively charged ion nutrients. Another great practice for this is sending in leaf tissue analysis. So getting some lab results that indicate what nutrient levels are in that sample itself. Most labs are going to give you some recommended ranges, which is a great idea of keeping track of the different components in that composition.
Yep. That's so that's always helpful to know. And that leaf tissue analysis is pretty common in other industries. It is rarer amongst cannabis growers, as far as from what I've seen in talking to people. But the people who are very scientific and nerdy about growing do send tissue samples in to get that constituent nutrients analysis in the leaves. Let's talk a little bit about stomatal conductance, because we did get a question on that. And specifically, let's talk about stomatal conductance and EC, like running high ECs or stressing the plant. So we got this question, do we sell a stomatal conductance sensor? And the answer is yes. And since this has the theme of a family broadcast already, I'll say that our stomatal conductance sensor was designed by my genius brother many years ago, and is a great way to measure to get a stomatal conductance reading and look at the photosynthetic activity of the plant without buying a full-blown photosynthesis analyzer. And we do have customers that are using these and seeing really interesting, getting interesting and important results. Gaylon, what would you expect to see on from a stomatal conductance from our parameter? We call it a leaf parameter. What would you expect to see at different phases of plant growth? Like, let's say maybe when you're steering the plant generatively versus steering the plant vegetatively.
Well, I wish we had enough data we're in the process of collecting that kind of data now, and haven't gotten a very complete picture yet. And some species are well studied and a lot of data around, but I've not found a lot of data in the literature either that shows that. But in general, stomates are more open in the day than at night, so the conductance is higher in the light than in the dark. And we would expect if the plant was stressed that the stomates would close. So during generative steering, we'd expect to see lower stomatal conductances. And usually as leaves age, the conductance goes down. So we would expect closer to harvest to see lower conductances.
Yeah. Yeah. I mean, anecdotally, and when I take the leaf barometer in, have taken it into cultivation facilities, I see lower stomatal conductance on plants that are being stressed, and higher stomatal conductance on plants that are being steered vegetatively. But it it will take some use of that leaf barometer and getting comfortable with it to say what those readings mean. And you can log those in the Arroyo journal, the readings, the stomatal conductance readings that you take. So the key thing about the barometer and the reason why we sell it is that instead of looking at what conditions the plant exists in, you're actually taking a primary measurement of what the plant is doing. And so this is a reason why it's an important reading. But it does take some expertise and dedication to get that to make that information useful.
And I'm gonna chime in here just a little bit more to talk about what is driving that stomatal conductance. So when we talk about stomatal conductance, the higher your stomatal conductance, the more water vapor leaving those leaves, and so that's going to be transpiration rate. Typically, higher transpiration rates mean that we can build biomass faster. And what's pushing that stomatal conductance is a multitude of factors. So it's a good balance in your environment and a good nutrient relationship with how that plant is growing. When we look at ways that you can modulate or change that stomatal conductance in attempts to get it up there as high as possible is definitely looking at your VPD. So vapor pressure deficit is going to be talking about how much vacuum is the environment applying to that leaf surface. And that's going to really dictate how much those stomatals can be open or closed. If we've got an environment that's too hot and or too dry, or the combination of the two, those stomates are going to close up so the leaf can retain water and not wilt. When our VPD is too low, so an environment that's too cold and or too humid, there's not necessarily enough pressure in that environment to be pulling water, enough transpiration. So getting a good VPD balance and looking at VPD charts to hit the right humidity for the temperature that's desired in that plant is one of the ways that you can go to optimize stomatal conductance. So going in the room, taking stomatal conductances over a good sample in the room, kind of analyzing that model, setting that as a baseline, and then when you do make any changes to environmental conditions or nutrient, what the substrate feels, kind of get an idea of, hey, is that baseline, am I improving on that baseline or is it going down? And that's a great way to understand if the changes that you made were felt appropriately by the plant for improvement.
Yep. Yeah, so if I understand you correctly, it's a diagnostic tool that you can use to look at potential problems with your environmental conditions in your rooms. Temperature and VPD being the key ones that would affect how that the work rate of the plants in the room.
Absolutely.
Yeah. Probably more important than for diagnosing those problems than for looking at the plants and seeing if the steering is having an effect on the stomatal conductance rate. Okay, so we do have a question about the ES2. So the ES2 is inline. So you can think of the Terrace 12 as measuring the electrical conductivity in the substrate. And a lot of questions that we get have to do with what's happening in the feed EC. And this is something that was hard for me to understand in the beginning because many people that we talk to run their feed ECs at totally different levels. Some people down at 1.3. I've heard as high as 4 before as well. So, and it's like, well, how come there's so many different opinions on this? And so let's just say about the ES2. The ES2 is a way just to stick a sensor in a pipe and measure what your feed EC is, which is helpful to know because that's driving what's happening in the substrate. But it doesn't it doesn't just follow that if you're running a higher feed EC that you're going to have higher EC in the substrate. Am I right about that?
Yeah, the nice thing that the ES2 is providing is an understanding of an input, right? So when we're looking at a substrate, it's what the plant is doing. It's a very dynamic area. When we're looking at the ES2 sensor, that feed EC, it's nice to have a line of comparison, right? So if we are feeding it, say 3 decisiemens per meter, we can see, is that substrate floating, nominally about 4 EC, or is it nominally floating about 5 EC? Things like cation exchange capacity in your media type can affect what that difference is and that fluctuation. So that's exactly right. Your EC in your substrate's not always going to follow the EC from your fertigation line.
Mm-hmm. Yep. Anything to add on that, Gaylon? And maybe I don't know if this graph here is helpful to look at. Any additional points on feed EC versus substrate EC and why they're different?
Well, we can think about why the substrate EC would be lower than the feed, and that would have to be because the plant was taking up nutrients, and it's higher because when the plant takes up in proportion more water than nutrients. And so you can see, if you look toward the end of the day, this shows a 1-day period with an irrigation event and then a quick drop in water content during the light period. And then you can see about 3/4 of the way across the water content stops dropping. That's when the lights go out. But you can see that the EC the pore water EC is going down during that time. The only way it can go down is if the plants take up nutrients. So that's an indication of the nutrient uptake by the plants.
Yep. Okay. Let's see.
Scott and Jason, I actually have a question here on the chat.
Yep, please.
Jose wrote, sometimes on the graph, we will notice the EC data cruising along a certain EC, while the water content will do what it usually does, going up then drying back. Would this have something to do with how the plant is responding, or is this more than likely the placement of the sensor?
It could be both. It could be a combination of both. We do send out sensor placement tools, templates with all of our kits. We absolutely recommend that be used. When we look at the volume of influence in this sensor, we really want to try and get an average of that substrate volume. What is the expected value the bulk of those roots are feeling? So when we look at like a perched water table or the gradient of water from top to bottom of the substrate, it's imperative that sensor be placed in the right vertical level to capture that. If we've got it too low, it's likely going to read higher than the bulk water content of that substrate. If it's too high, it's probably going to be a little bit drier. So shooting for that range based on our recommendations with that sensor template tool can avoid any placement issues. That being said, if it is in the right area, it could definitely be an indicator of that plant responding, maybe not necessarily being very active as far as pulling nutrients or possibly pulling the exact amount of nutrients that you're supplying to.
Yeah, and also, Jose, if you're interested, I'm happy to look at your specific data with our customer support team, because it could be that there is a problem with the sensor. Those are really uncommon, but it would be easy in looking at your data to say whether that might be a placement issue or it might be an issue with the sensor itself. As Jason said, it is really important to use the alignment tool. We call it an alignment tool to consistently place those sensors in the same location in the substrate every time. And that's one of the critical pieces to getting good, repeatable data. I will say, though, that in all the times that I've looked at my data from when I'm irrigating the plants and looking at the response, that in many cases, most of the cases that I've seen, the EC is changing when the water content changes. It's not necessarily for sure that it's opposite to water content, although with the consistent irrigation events, you will often see EC moving in the opposite direction from water content.
Could I just make a quick comment?
Please.
If you think about the processes that are going on, that the electrical conductivity, the salt being leached out when you have drainage, the salt being taken up by the plant, the substrate being either leached or replenished by the water coming in. All of those processes are going on at the same time. And so what will happen to the pour water EC over the period of the day will depend on the sum of those things. And if you've chosen a feed EC that is just sufficient to supply the nutrients that the plant's taking out, why the electrical conductivity won't change very much over the period of the day, even though the water content does change quite a bit.
Yep. Yes. So thank you for that.
And just a clarification here, we've got a comment asking about placed vertically, and I just wanted to clarify the terminology that I used there, and I'll share just a quick view from our installation guide. The sensors should be installed with the prongs horizontally. What I was talking about is a critical vertical height at which those prongs are inserted vertically. So hopefully this clears any of that up, and you can see that installation template tool that we recommend for different sized medias.
Yep, thank you. Let's go to sensors reading 0, a 0 EC sensor. What does that usually mean?
So if we're looking at 0, it could be where there's absolutely no nutrients in the solution. One of the things I do like to keep an eye on is if we've got a really low water content, it also could mean that that EC is so high that we can't read it. So our sensors, we cap out that reading at 30 decisiemens per meter. If it gets too much higher, over 30 decisiemens, sometimes that graph will show it at 0. So if you do see 0 decisiemens, look at your water content. If it's really low, it's probably talking about, hey, we've got a serious salt concentration here that the sensor can't accurately read. So it's out of range.
Yep. And I would like to point out too that, relative to water content, we have had people say, well, I just took my Arroyo sensor and I dunked it in a bucket of water and it didn't read 100%. And that's because, the vast majority of our growers are not growing in buckets of water. So the sensors are created to use in in hydroponic media and even in soil. Although if you are looking at water stress in soil, it's going to, you're going to be much more interested in matrix potential than you are in the the pour water EC. So that's something to definitely keep in mind. But if you dunk Terrace 12s in buckets of water, you're not going to get 100% reading. And we do have a related question on what is typically the highest water content that we see in cocoa?
So with cocoa specifically, looking at the chip and pith size, so manufacturer to manufacturer, there is differences in that field capacity, that saturation point at which we do see runoff. For most of the cocos that I've experienced, looking at ranges of say 40, maybe 45%, all the way up to about 55%, depending on pith capacity.
Yeah. Yeah, and cocoa, as Jason mentioned, can show a lot of variability. And in some cases, when the chunks are massive, they can even create large air gaps in the substrate, which are not necessarily conducive to good growing or good readings either.
That's exactly right. And just like some of the irrigation channeling that we've talked about in past videos here, when there is big pockets, and I think one of the questions was a little bit about perlite in here as well. If you've got large chunks of perlite that are sitting right next to the prongs, if that thing turns into a reservoir for water or it turns into a reservoir for air, that sensor may not necessarily be a great representation of the substrate. And it's also kind of a testament to some of the ability of rock wool being a very homogeneous substrate, is the sensors work very well and very predictable because that continuity with the substrate, that the way that the substrate is consistent around the prongs, right? And it's not necessarily a big issue with good cocoa manufacturers because they do have a consistent product across that bag. But in any hand mix types, anything that's got soil or amendments, you definitely want to take into consideration some of that, especially during your installation.
Yep. Yes. We have an unrelated question to EC, which is why are Aqualab water activity meters so expensive? And I can tell you that being a small manufacturer of customized devices, which is what Meter Group is, Meter Group and AROYA within Meter Group, it's really hard and very difficult to make an instrument that measures things correctly every single time. And that's the dedication that we put into products like Aqualab that measure water activity. We'll probably talk about water activity on a different office hours, but let me just say that that yes, relative to something like a wood moisture meter that you buy at Home Depot that uses two prongs and that you shove into a 2x4, an Aqualab precision water activity meter that's accurate to 003 water activity units is expensive. I do agree with that. But the key is that by measuring water activity, you can protect your crop and increase your quality while improving your profitability as well. And we'll talk about that a separate time. But if a grower says that water activity is expensive, I would say it's way, way, way less expensive than having to recall your product because of a mold problem. So price is what you pay, value is what you get. And the value of water activity and of crop steering, for example, is just in how it affects your productivity as a grower. So I have another question about, hey, I have an 8-light setup that's not automated. How would the AROYA sensor benefit my grow? I mean, for the most part right now, AROYA is a business-to-business product. You do have to have your, we do ask you for your license number. We sell to licensed growers. So assuming you're a licensed grower with an 8-light setup, the AROYA system can benefit what you're doing, but it's not as useful if you don't have irrigation automation, if you're hand watering things. Still, there are a lot of benefits that you could get by starting to capture data and look at how you're steering your crops and even make decisions if you are hand watering. Should I go out and water and how often and with what duration, even down to how your cultivars are grown. So mostly the power of AROYA is much higher with automated irrigation, drip irrigation systems. but it can still apply to smaller cultivators. It's just maybe less powerful, is my opinion. Jason, any thoughts?
Yeah, absolutely more difficult to get to the point that you want without that automation, right? So obviously being able to have insight into your substrate and understanding of what you're doing currently is very, very important, because you can make small modifications to how you're treating those plants. But without automation, you would have to be spending maybe all day in there giving the water shots at the right time so that you can achieve the types of crop steering that you want. Now, obviously, that is on the performance side of things. If you want a system that just can monitor and help you alert when parameters are going way off the wall, then any type of sensor system is going to be helpful to keep an eye on what's happening in there.
Yep. Okay, we're down to general questions. Here I have a question: why Arroyo over GrowLink? So that's a question about a competitor, a competing system. And I think, the way that we think about competitors at Arroyo is that we love it when other people are out there seeing what we're doing and excited about something like crop steering and saying that it is important. And I think we see a lot more interest in the marketplace in something like crop steering, seeing that we broke that ground and helped the industry to understand how important it is to getting good yields. The biggest difference between us and other companies, and the simplest way that I can explain it, is that Terrace 12. It's a sensor that we have spent the last decade perfecting. We started out with it in soil, but started working with some of the largest indoor growing companies in the world, and meeting their requirements in terms of accuracy, performance, and durability for a sensor that is going to deliver results. And at the end of the day, the most important thing for achieving results is getting accurate EC readings. And as I mentioned before, the Terrace 12 is the only sensor that I've ever seen that can measure with accuracy and consistency that can measure with that high of a level of accuracy and consistency in a hydroponic growth medium like Stonewall or like cocoa. So, that's the foundation of what we do. We are a group of scientists. The company was founded by my dad out of academia, and we bring that spirit through to the product. We're not a controls company. We're not we are not a ERP vendor. We focus on increasing yield for our customers, and that's why we're having this conversation around the science of EC. So I think that's the biggest difference between us and other people is the Terrace 12. And I can tell you, I'm sitting right now in Pullman, Washington, and that's where we make the Terrace 12 as well. And so, we're 100 feet away, sitting 100 feet away right now from where those sensors are made. And they came from our researchers, and and we make them and send them out to growers all over the world. So that's what I think the big difference is.
And I might just add the second next step to that, and that was pairing that Terrace 12 with a easy to use system. When I talk about easy to use, I do absolutely emphasize the software. We've got a lot of investment in developing this next to our growers. We've got years of research with projects where we go out, visit people, use designers, use UX, UI professionals, and implement the tools that the client needs based on how they're operating. And on the hardware side of ease of use, we have a system that is quickly deployed. So the wireless sensors themselves are a very unique solution to grow rooms that may already have a lot going on. I was recently at a facility where some of the wires on a competitor system were severed by the rolling benches. They had some knots in them, etc. And so, when we think about having a reliable system, it needs to be easy to use, easy to implement, and the wireless solution of those substrate sensors keeps the configuration simple, and it makes rooms clean.
Yep. Yeah, and I do appreciate that, and I will also say that another big difference, and I mentioned this before, but Gaylon, Jason, people like that that have experience and take a scientific approach to growing. That's the difference as well. So it's the simplicity that Jason mentioned. It's the design thinking that we've put into a system that can be installed in a matter of hours. You can be up and live, getting data streaming into your platform. To the science that sits behind the sensor itself. All those are critical in terms of delivering results. And everything that we do, all the efforts that we make is focused on one thing, which is to increase grams per square foot per year for our clients. The last question on our list is plans. What are your plans for rolling out a system for personal or small rooms? And I will just say yes to what are your plans, because we don't really have anything to share at this point. We would like for the system to be, how could we put it, self-provisioned or self-deployed. And right now, if you buy a system, we set up your facility, our team sets it up, and then we deploy it by provisioning it in-house before it ever goes out to your facility. So it makes the process really simple for you. But if we were to do things and focus on smaller growers, smaller producers, we would have to get something that was a lot easier to deploy than that. And we are working on that. We don't have anything to share at this point, but we do understand, just because we check our Instagram, we do understand how badly people want this. So I don't know if you have anything to add, Jason.
I don't.
Okay. Gaylon, did we miss anything in the EC? I mean, and let me just say that Gaylon gave a presentation on EC that was tremendous, and I just showed a few slides from that today. We will link in the description that entire seminar if you're interested in watching it, because it's chock full of great information for growers and was specifically formulated for people who are growing in controlled environments, which is what Arroyo customers do. But Gaylon, did we miss anything you wanted to hit before we sign off?
Probably not. There's, with respect to the diffusion parameter and stomatal conductance, there's another the webinars in that same series that talks about how to use those kind of data.
Yeah, that's the exciting part. It's not just this one seminar on that, but it's a series of 4 seminars. I think what are you on? Number 4 coming up soon? Is that right?
Well, we've just done number 3.
Okay.
Haven't scheduled number 4 yet.
Haven't scheduled number 4. Yeah, it's meant to be a comprehensive look at the foundational technologies that make Arroyo possible, and is really a lot of great information. And one of the most important things, explained in a way that people who don't necessarily have a scientific background like me can really understand. So
there was one other question,
okay,
that I saw at least that we could address. The question was, what's the relationship between parts per million and electrical conductivity?
Okay, yeah.
And that relationship is specific to the whatever salt is in the solution.
Yep.
But for nutrient solutions that are, at least for a couple of nutrient solutions that are used for cannabis, it ends up pretty easy that something like 1,000 parts per million is about 1 decisiemens per meter. But if you have table salt, for example, 1,000 parts per million would be 2 decisiemens per meter. So it depends on the salt that's in there, but it's not a difficult thing to determine that relationship. You just mix up a few different solutions and measure their electrical conductivity, and you can work it out for whatever solution you happen to be working with.
Yeah, and just to kind of expand upon that on how some of our growers use it these days, I would like to start off that EC is the native measurement that the electrical conductivity is measured in. So we would need to derive ppm from a conversion factor. One of the things that I always talk to growers about when they're used to using ppm is that understanding that, hey, you might as well go from the natively derived measurement, and the fact that there is also a number of ppm scales. And so that can get confusing if you're talking about ppm, but there's not necessarily the scale that is specified. It's easy to be way off in that nutrient concentration. And with EC, you've got only one measurement type. That's one ratio, and it's uniform across whatever you're talking about.
Yep. Okay. I think that about does it, Keisha.
I think you're right, Scott, Jason, and our special guest, Gaylon. Thank you so much. What a great session. Thank you to everyone who joined us for this week's AROYA Office Hours Live. It's our last one for the year, but this is your time. Any questions that you have about AROYA, how it can be used to improve your cultivation production process, any topics you'd like us to cover in future office hours sessions, please let us know. Feel free to put that in the chat, shoot us an email at support.aroya@metergroup.com, or send us an Instagram DM. We definitely want to hear from you. We record every session, and we will email everyone in attendance a link to the video from today's discussion. It will also live on the AROYA YouTube channel. Please like and subscribe while you're there. And if you find these conversations helpful, definitely share them. Share the video with anyone else who might find this information useful. We look forward to seeing you all in 2022. Happy holidays, everyone.
Yep. Happy holidays.
Thank you.